Happy Saturday. Is everybody able to see my screen and hear me okay?
Yeah, you good.
Cool. Yeah, so feel free to type in the chat when I ask questions if you're too shy about talking out loud. I'm gonna wait maybe 2 more minutes until more people join. In the meantime, how is everybody Saturday? Or have you been noodling over the problems that we went over last time? Or maybe you could just type out what you did between Tuesday and Saturday. If you study any leak code problems that you found that was really interesting. Is anybody trying to start a habit where you try to do like 1 or 2 leak code problems a day? Just trying to get into the habit of consistent practice. Yeah, so for those people who aren't doing it, I highly encourage that. One, I think it's a good thing to kind of continuously think about these problems, but also building a habit of practicing problems, I think, is a really good way to start getting more familiar in the mindset of solving these problems. So highly encourage it if you're not already doing it. Yeah, so one of the problems that we went over last time was the task schedule problem, right? That was the first problem that we went over where we kind of talked about it for a bit. We ended up with a not so efficient solution. And as a reminder, for this whole week, we're focusing on the greedy concept, right? And last week, or on Tuesday, we talked about this task schedule problem, and we came up with a kind of workable solution, but it wasn't quite efficient yet. And the second problem we went over was the activity selection, which we'll go over later in class as well. Okay, cool. So I guess I'll just go ahead and get started. So if you remember, last Tuesday, one of the first problems looked at was this task schedule problem. And this whole week we've been focusing on greedy approaches, right? And the first problem that we kind of started thinking about is this task schedule problem. Basically, the problem boils down to we have a bunch of tasks that we want to do. There's 26 different kinds of tasks. And we're basically the CPU that's trying to schedule this task in the most efficient way possible. So we just get a list of tasks that we need to do. And the other constraint we have is that there's this cooldown time, which means that between doing two of the same tasks, we have to wait for a certain amount of intervals before we can do the same task again. So our goal is to return the least number of intervals that the CPU needs to take to finish all the given tasks. So for example, if we're given like AAA and BBB, so A's are one type of task, B's are a different type of tasks, and then we have a cooldown period. In this case, the cooldown period is 2, right? And our end goal is to just output 8. 8 because 8 is the number of CPU cycles that we need to complete all this task. So this is just something we went over last time, right? Hopefully everybody remembers this. And eventually we came to the conclusion that we're gonna have this array that's size 26, and this array represents the cooldown time left for each task, because each task has a certain amount of time before it can be executed again, right? So in the size 26 array, it's size 26 because we have tasks A through Z, and since there's 26 letters in the alphabet, we have this size 26 array to represent the 26 different type of tasks that could be presented. So we iterate through each task, we try to schedule a task to run, and then we basically check this array to see if we're allowed to run it. And every time, after every iteration, we update our array, the cooldown time left array, to say, okay, this is how many more cycles that we need to wait before we can complete this task again. So for example, if we had 4 tasks that we wanted to schedule, A, and B, C, and then we wanted to schedule the A task to run first, we would have to update our array, and the first index needs to be 2, right? So this is hopefully all review. So this is the basic approach that we came up with. But then we decided that it's inefficient because, one, we have to remove and mark tasks from the array every time it's scheduled, right? So every time we schedule a task, we have to go back to our array and say, oh, okay, now we have to decrease it by 1 cycle to make sure that we know when we can run it again. 2, we're repeatedly checking to see if we can run a task. So every time we're trying to run, for example, task A, we're checking the index at the index A to see if the cooldown time has been completed so that we can run it again. And 3, insufficient because we might end up scheduling frequent tasks at the end, right? So the biggest problem with our approach that we came up with last time was that if we have a certain type of task where we have to do it a lot of times, we want to run those as soon as we can. So for example, if we had like a bunch of A tasks that we want to run and then the B, C, D, and then our cooldown time was 2, we don't specifically want to run it where we go A, B, C, D, and then A, and then have to wait a bunch of idle cycles before we can run A again, right? Because that's not very efficient. While we're waiting for us to run A again, we didn't have to run B, C, and D. Instead, it would have been more efficient if we did like A, B, C, and immediately after we can run A again, we try to run A again. And instead of like running through all the individual tasks first and then going back to A again. This way we could save more idle cycles, right? Does that kind of make sense for everybody so far? I'm kind of going through this a bit fast, but hopefully it's okay because we did kind of go over it on Tuesday. Does anybody have questions about this so far? I'll just give it a minute for everybody to let it sink in. Yeah, so someone suggested that, hey, maybe we could use max heap instead, and that would be more efficient. Did anybody else come up with any other ideas about how this could be more efficient? Mostly we're trying to solve the problem of it being efficient because we don't want to schedule all the individual tasks first, the unique tasks first, before we could schedule all these like frequent tasks. So did anybody, for all those people who did spend some time thinking about it in the last 4 days, is there any ideas about how we can make this more efficient? Or did you leave class and then forget about this problem completely? That's totally fine too. Seems okay. Okay, cool. So one of the someone said you could sort by the number of instances, right? That's a really good idea. Yeah, and another idea is instead of storing the time left for cooldown, you can store the time that it was last ran. So that's a cool idea too. I like it too. Greediness is indeed not a virtue, but sometimes it does solve our problems when we're trying to solve LeetCode questions. Okay, so my idea is that, like someone else mentioned, maybe instead we could sort by the most instances first so they can run first, right? So regardless of whether we've already ran something, we don't care about what was last run, but we care about which instances we want to run first. But as we figured out previously, we can't just like run the most common task first and then wait till the end to run the last, right? Because if we do like A, B, C, and we sort it, we don't want to run it like A, B, C, A, right? We want to run it as soon as we can. So my idea is that maybe we could be more efficient and then sort this array again after the cooldown period has passed, right? Because basically, if we're sorting it the first time, we want to resort it again after every cooldown time has passed. It doesn't make sense to resort it after one task is run, because even if one task has run before, it means that other tasks that are still waiting for more cycles to go through might still need time before it can run again. So it only makes sense to sort this array again after a cooldown period has passed, so that we could be like, oh, okay, now we know this cooldown period has passed. Now for sure, we can run the same task again, because at most, the time it needs to be run again is the cooldown period. But then I kind of thought about it, okay, how do we even sort, right? Because these tasks are just letters. So these are just like A, B, C, D, E, F, G. Like, what does it even mean to sort this task, right? But really, if you think about it, our first idea was to put these tasks and their instances in a hash map, right? But if we put them in an array, we could sort them. And just because these tasks are like A, B, C, D, we don't really care about what the actual task we're running is, right? It doesn't matter if we're running task A or we're running task G. In the end, we're really just trying to run all these tasks, right? So once we know how many instances of a task we need to run and what the cooldown time is, we don't really need to, like, we don't care whether we're running task A or task B, right? We're just trying to get all these tasks to finish. So it really doesn't matter. So in the end, it kind of comes down to this. So we're given this input, a bunch of Bs, some random tasks, and we have a cooldown time of 2, right? Where one of the first things we need to notice is that we're not just given these tasks in a specific order. You can notice that Bs are kind of like spread around, As are kind of spread around as well. So the first thing we kind of need to do is count how many of each task there is. So we go, okay, we have this array. We have 3 Bs, 3 As, 5 Bs, 3 Cs, or 2 Cs, 1 D, and 1 Z. And then once we have this information that we need to start the problem, then we put everything in an array. Does that make sense so far? So basically, we're given an input of letters, and the first processing step that we kind of need to do is just to count how many instances of each task we need to complete. That's just the first processing step so that we're set up to actually do the rest of the problem. So we go through this input of a bunch of letters. We count how many of each letters. So hopefully we can probably just do this by creating a size 26 array. And every time we see B, we just update the second element in the array. So now we have this size 26 array. So the first thing we do is sort these tasks by frequency, right? So we had 3 A's, 5 B's, and 2 C's. And next, we want to sort it by frequency. So at this point, we don't really care about the kind of task we're running anymore, right? Once we sort the task by frequency, we have 5, 3, 2, 1, 1, right? We're just sorting from biggest to smallest. And now you might be thinking, okay, now we don't know what like the 5 stands for anymore, right? We don't know anymore that the 5 stands for task B. But the great thing is we don't really have to care about what that 5 stands for. Does that kind of make sense? Because we're just trying to run all these tasks. We don't really care at this point what kind of tasks we're running anymore. So we're just sorting tasks by frequency, disregarding what kind of tasks we're running. So the first iteration, we have a cooldown time equals to 2. And so the first time, we have to do this task that has 5 instances, right? We don't care about what it is. Even though before we knew it was task B, now we don't care about it. So now we do the first thing, the first task that has the most instances. So now our array is like 4, 3, 2, 2, 1 because we ran the first task once, right? And then we do the second iteration. Now cooldown time has gone down by 1. So then we do the task again at index 1 because we want to progress in our array as long as the cooldown time hasn't gone over yet. So now when we run the second task, now the second task only has 2 more instances to run, right? So now, okay, we're like, okay. So now we're running the third iteration, and now the cooldown time is 0. So now we're doing the task at index 2. So now our array looks like 4, 2, 1. So every time we're running it, we're moving 1 over in the array, but we're also decreasing the number of times we have to run this task. So finally, now our cooldown time is 0. So now that our cooldown time is 0, we move our index back to the front of the array. So it looks like 3, 2, 1, 1. Does that make sense for everybody so far? So basically, we inputted this array of all the tasks we need to run. And then once we have that, we sort it. And once it's sorted, we know exactly like which task is the most frequent. So the task that we have to start running first. And then we go through the array and try to run the tasks one by one while the cooldown time is decreasing. When the cooldown time goes down to 0, then we go back to the front of the array to run the most frequent tasks again. So that's our approach. So if you're thinking about it now, can you think of anything that we're missing at this point? So right now, our approach is kind of like, okay, where we make the array, we sort it the first time, and then we iterate through it while the cooldown time is 0. Once the cooldown time goes down all the way to 0, then we go back to the beginning of the array. So can anybody see like a flaw with our approach so far? Is there anything wrong with our approach so far? It might not seem like there's something wrong with our approach so far because I gave it very nice and tidy solutions. Okay, so there's a bunch of people pointing out stuff, but yeah, that's great. I think the basic thing is that if the cooldown time finishes, we have to restore it, right? Because what happens when we have something like this? We have like 5, 3, 0. We run the first task, decrease the number of instances run. We run the second task, decrease it again. The second iteration, after we run it and the cooldown time has gone to 0, if we go back to the, sorry, what's going on? Does the audio sound weird? That's weird. Okay. Does it sound okay? Is it sounding okay again? Yeah, that's how I'm so good at all these algorithms. It's because I'm actually a robot. Okay, I have no idea what happened, but let's see. Okay, so maybe I'll just go back down to this. So the problem was that we were asking, okay, anyway, I don't know what happened, but I'm gonna go back just to recap. So the problem was that we were doing this every time the cooldown came back to 0, we went back to the beginning of our array, right? So we went back to the beginning of our array because now that the cooldown time is 0, we know we can run the same tasks again. But the problem is that we have to resort every time our cooldown has run out. And that's because of something like this, where you have all these tasks, you run it, okay, you decrease the number of times you have to run it again. But then now, if our cooldown time was 1, by the time we get to the third iteration, the 3 in blue, we're never going to actually get there because now we're moving our index back to the beginning of the array, right? So now our third task, whatever it is, we don't care about whether it's like A, B, or C. Now our third task is basically never going to get run until it's too late, and then it's going to be inefficient. Does that kind of make sense? I'm going to leave this here for a bit so you can read it. The basic idea is that if we have, so for example, if our cooldown time was like had a very small iteration, so if our cooldown time was 1, we're basically going back to the beginning of the array very often, right? To redo those tasks because we know we can do those again because the cooldown time has passed. But the problem is that now we have these very frequent tasks that haven't been sorted the first time. Now they're not going to get run until it's way too late. And now we're going to have to waste these idle cycles. So it would be great if we could resort it after the cooldown time has passed. So someone asked, wouldn't the second iteration start with 3320? Wouldn't the second iteration start with 3320? So we started with 4330, right? That was the first iteration. The 4 comes from this 5 being decreased. When we go to the second iteration, we're doing 4230, right? This is a little different because the cooldown time is only 1 this time. So now at 4320, the cooldown time is 0. So that's why we go back all the way to 3230 again. So I think it's different because the cooldown time was 1. We started with 533 and cooldown time 1. Now at 433, the cooldown time is, so it's different because the cooldown time is 1 less. Yes, so we do want to resort again. We want to resort again, so that's the more efficient solution. The inefficient solution is if we didn't resort again. That's how we got this. So this is the inefficient solution, if that makes sense. Yeah. So our final approach, just to like kind of recap everything, is 1, you want to store our task instance in some kind of size 26 array, right? And each element in the array represents the number of instances the actual task needs to run. At this point, we don't care about what kind of task we want to run anymore. And then the next time we want to sort the task, next thing we want to do is sort the task in descending order. This way we get to work on the task with the most instances first, right? Because if we're sorting in descending order, the tasks that need to run the most frequently come into the beginning of the array. And then as we have this nice sorted array, we iterate through it while the cooldown time is not 0 yet. Because we don't want to go back to the beginning if we can't schedule a task to run when the cooldown time, not enough cooldown time has passed. Finally, when the cooldown time is actually over, then this is when we can resort the array. So this is when we can resort the array so that we could do those most frequent tasks in the beginning so that we don't have to waste more idle cycles in the end. So finally, when we're finished, we know we're finished when the first element is 0 after resorting. Does that make sense? Because if the cooldown time has reached 0 and we resort it again, and the biggest element is now 0, that means we have no more tasks we need to complete. So that's how we know we're finished. Does that kind of make sense? Oh, okay. So why do we need a size 26 array when we don't actually care about the type of task? So we need the size 26 array because there's 26 different kinds of tasks, right? So for each task, at the minimum, we need to know like how many times we need to run it. The 26 might be a little bit inefficient because we might not have like 26 different types, but it's hard to know how many types we have, right? But if you have like a more efficient way to figure out how many types of tasks there is, you probably don't need the size 26 array. Okay, so this is another good question. So when you're sorting it, do you need some way to keep track of which new index goes to which letter? So that's the genius of this whole thing, right? You don't actually need to, once you've inputted how many times a task needs to run, you don't actually need to know like which task you're running, right? You just need to know how many times you need to run a certain task. That's like the only thing you need to know, because in the end, the only thing we want to output is how many cycles that you need to run all the tasks given the cooling time. So we don't actually need to know like what type of task we need to run anymore. We just need to know how many times we need to run each task. Yeah, I think a priority queue would be a good way to use it too. So a priority queue is like a built-in way basically to do all this stuff with a nice built-in library. Does anybody have questions about this so far? These are great questions. Right, yeah, a priority queue or a heap would automatically do the sorting for you. Yes, also very true. The priority queue would update every cycle. If the cooldown time is greater than 26. That's interesting. Yeah, so I think this is a good edge case to consider. Like, what if the cooling time was greater than 26? Does anybody have ideas about what if the cooling time was greater than 26? Like, is that something you think we have to worry about? So I think if the cooling time was like greater than 26, let me think about this. I think if the cooling time was greater than 26 and our array was only 26 and we're iterating through the array by incrementing it once every time, I think we would have to do like an extra check just to make sure that we're not still trying to iterate through the array while the cooling time is still trying to go down. So that might be like a good edge case to consider. Yeah, so that's a good like edge case to kind of think about before you actually start coding. Cool, so this is my general approach to the problem, but I haven't thought about this too deeply yet, but I think there can be an even more efficient solution, right? Because we're doing all this like resorting and we're doing all this resorting just to actually like schedule the task to run. But in the end, we only really need to figure out like how many idle slots are needed, right? Because our end goal is to figure out how many cycles we actually need to run all these tasks given a certain cooling time. But if there was some like super efficient way where we just know like how many time, basically we know how many tasks we need to run. We know what the cooldown time is. We really just need to know like how many idle slots we need. And then we can add that to the number of tasks we actually have to run. So we don't really even have to schedule all these tasks and actually go through the process of scheduling each task and waiting for the cooldown time and actually like building out this array of like which tasks we're running. We really just need to figure out like how many idle slots we need, right? So if there was some efficient way where you could only figure out how many idle slots you need, I think that would be the most efficient, because then you wouldn't have to go through the whole process like resorting the array and then waiting for the cooldown time to go down and then resorting the array again. So I think a really efficient solution, I don't even know if it's possible because I haven't actually tried it out yet, is if you were able to just figure out how many idle slots are needed based on the task you have and the cooldown time. Is that possible? I'm not sure. So if you have time and you're interested, that could be something interesting to think about. But even though we talked about all this approach, I really highly encourage everybody to actually try coding up their approach. Because a lot of times with studying problems, it's like you look at a problem and you're like, oh, okay, I know exactly how to approach this. I'm pretty sure I know how to solve it. But once you get to the actual coding part, that's when you actually start thinking more deeply about the problem itself. And you actually like get to problems like, oh, okay, how do I even actually like resort the array, right? Sounds easy when it's all listed out in these steps. It's a lot harder when you're actually trying to code it up. So this is like the part of the planning phase, I feel like, in the whole Empire process where you're like trying to understand the problem, you're trying to like plan out the problem. Now you actually have a pretty good idea of how to solve it. Now you actually want to try to implement it. I think that's how you can really learn the problem. So we have I laid out all the steps that I think would help you solve the problem. But your job, when you have the free time, is to actually try solving the problem. So the task editor problem is on LeetCode. So I highly encourage everybody to actually go on LeetCode and try solving it. Okay, so going into today's session, we're going to do more mock interview, right? I think one of the questions that a lot of people had, and a lot of times I see as I go into rooms, is people don't really know what to do when you're stuck, right? So this is the time when you see a problem and you're just kind of like thinking through the solution, but you don't know how to get started. So what are some ideas that people have? Like, what are things you like to do when you just like have no idea where to get started? You see a problem and you're like, I have no idea what to do. It happens to me all the time. I'm interested to see like what other people strategies that other people have. Like, what do you do when you get stuck? I think it's this is like a more general question of like what to do when you get stuck in an interview. So if you're like stuck on an actual phone interview, what are some things that you kind of do to help you get past this funk? Okay, cry is a good one. Make a very small test case. Yeah, I really love that one. So making small test cases to help you better understand a problem, I think that's a really good one. Open up LeetCode. Yeah, sometimes when you're stuck and you're like practicing, I don't think it's very productive to get stuck for more than like 15 minutes. Opening up LeetCode solutions to see what other people have come up with is a really good idea. Small examples, my favorite. Try to actually understand the problem more. So sometimes when you're stuck, the problem might be that you don't actually fully understand the problem. So asking like clarifying questions could try to help you getting unstuck. Try to solve it intuitively. Yeah. So sometimes you might have a problem and you don't know how to code it up, but you can look at the problem and kind of figure out in your mind how the input becomes the output, right? So trying to like intuitively reason your way through how an input becomes an output also helps sometimes. Brute force is also a really good thing I like to do. Starting out with a brute force solution and then trying to work your way up from that is a really good idea. Yeah, so basically those are the same ideas I had. So my first thing that I like to do is writing out test cases, right? Starting out with smaller test cases is really helpful because if you have a really long input and you're trying to get that input, really long input to become the output, the process of thinking out how that input becomes the output is really long, right? In the beginning, you kind of just want to have a simple idea of how to go about the problem. So I like to write out test cases and think about how this input can become the output, just in my mind or through code. And the smaller the input to start with, the better, because especially for, I think this might apply more for trees, but when I have a smaller input, it makes it more clear to me how this like smaller input gets to the output, because then I have to go through less steps of each line of code or each step, and it's just a lot faster for me. The other thing I like to do is like start with an efficient solution. Almost every problem, there's like a really dumb brute force solution, right? If you could go through the dumb brute force solution and kind of think through the idea, as you're thinking through how this brute force solution works, you might have an idea of, oh, at this step, maybe I could optimize like this small thing. And as you're like going through your brute force solution, there could be more and more small steps that you take to make things more efficient. And in the end, you might just be able to reason your way through a more efficient solution. So, I mean, this is all like the best case scenario. So these are just things that I like to do when I'm stuck. Sometimes they help me get unstuck. So just like general ideas. So for today, we're gonna do more mock interviewing, because last time we did kind of like a solo studying thing, and that was nice. But getting back to mock interviewing is good because it's essentially what you're gonna be doing for your interviews, right? So we have two different problems today. You want to spend, so we're gonna have, we're probably gonna start around 10:30 in 2 minutes. So we're gonna stop at 11:40. So try to spend the first 10 minutes instead of 20 minutes. Just spend the first 10 minutes trying to understand your problem that you're gonna be acting as the interviewer for. Try to understand the problem. We have solution guides, so try to understand the solution. So the naive solution for every problem is usually pretty straightforward, right? You have like this brute force solution, but the optimal solution is usually like in the super clever, formulated in the super clever way. Sometimes when I go on LeetCode and I read through the most optimal solution, I have like, how the heck did people come up with this, right? I don't even get it. I don't, even after reading their code, I still don't get what they're trying to do, right? So a lot of times for optimal solutions, if I don't understand what's going on, I just take an input and I just like trace the code and see like at every line of the code what it's doing to the input to eventually make the input the output. So that really helps me understand the solution, because I'm like, oh, okay, it's doing this to the array, and that's how it eventually gets the output. And it's efficient because it's doing these really clever things along the way. So if you don't like immediately understand the optimal solution, try doing the exercise where you get an input and just trace through the code by hand to see what the code is actually doing to the input. So those are my tips for mock interviewing. So we're going to start soon, but the basic idea is we're still doing mock interviewing, but spend the first 10 minutes just trying to understand your problem so that you can help out your partner if they get stuck along the way. Does that make sense for everybody? Does anybody have questions? All right, if there's no questions, I think we're ready for breakout rooms. Yeah, so if you don't have a partner, then come back, but definitely wait a minute or two before you say you don't have a partner. They might just join a little later. to the main room so far. Did any group finish both questions within the 30, like an hour? So that means you would spend like 30 minutes on each problem. Any group, was any pair able to finish both? Sort of. Yeah, so I think one of the hardest things about these coding interviews is that it's easy to do it if you have unlimited time, right? But one of the things that you really want to practice is being able to do it fast, because you really only have, I want to say, like 30 to 45 minutes for each problem. Yeah, this week's problems are definitely a bit more challenging. But the way to think about it is it's almost a little bit easier because every week we've been focusing on specific topics. So when we give you a question, you already kind of know which data structure or which approach to use. So it's already a bit easier. So one of the things, that's why we suggest you do problems more than once so that you can get faster at it. But also when you're in an actual interview, it'll be even harder for you to kind of realize which data structures or which approach you might want to use, because it's kind of like a grab bag. Like they just give you a question and you're not sure if it's like a greedy thing, if you're not sure if you should use dynamic programming, you're not sure if you should use like stacks and queues. So that's going to be even harder. So if you weren't able to finish both questions, definitely encourage you to actually go in after class and try to finish this question and work on the extra practice problems that we suggested in the resources tab, because those are the questions that we think are most important for this week's topic. But to end the session for this week, I thought it'd be great if we can go back to the question we were talking about last week as well. So last week, before we ended the session, we talked about this activity selection problem, right? So the basic problem was that we're given a set of intervals, and these are basically activities represented by start and end times. And our job is to figure out the maximum number of activities we can do. So I think the example from last week was you could you could watch Netflix, you could like eat dinner and all that stuff. And the main problem that we will solve is we want to do as many activities as possible, right? Quality over quantity over quality. And then so our basic approach was we want to, since we kind of already know it's going to be a greedy approach, the first thing we want to do is sort the activities. And then we want to pick the first activity after sorting, and then remove all activities with start time before finish time. And then kind of do this recursively until we've gone through all the activities and picked out all the ones that we can do. But the hard part about this is the sorting activities part, right? How exactly do we sort? So we have like a couple different options. We could sort by start time, or we could sort by end time. But even beyond sorting by just start time and end time, we could sort by start time increasing or decreasingly. So we can either sort by start time by saying, okay, let's sort by all the activities that are going to start first, or we could sort by saying, okay, let's go backwards and sort by the start time, but let's pick the activities that are going to start last. And the same goes for end time. We could sort either by increasing or decreasing, right? So that was the hard part of what we were trying to figure out. Basically, how do we sort? So was anybody able to like think about this over the last few days and come up with some kind of approach? Or did most people just leave class and forget about this problem? So if you were thinking about this problem for the last few days and you have some approach, feel free to, tell everybody else about your genius approach before I go into how I kind of thought about it. So maybe we could just like do a little poll in the chat. So how many people did think about this problem? And if you did, just say yes. If you didn't, you can say no. Kind of just forgot about it. So wouldn't sorting by start time and starting from behind work? If we're sorting by start time and starting from the end, would that be just sorting by start time in decreasing order? So we have a sort by end. Okay, so we have one vote for a sort by end. If we sort by end, should we sort it by increasing order or decreasing order? Sort by end and increasing. Okay, so we have a lot of votes for sort by end and increasing. Okay, so let's kind of go through. So I'm going to walk through how I kind of started thinking about this, right? So the first idea I had was, okay, maybe we could sort by start time and then in decreasing order. So for example, if we have some activities like this, we sort it by start time and then we sort it by decrease order. But so for every idea that I had, I kind of tried to think of a counter example of how it wouldn't work to prove to myself that, okay, this could work. So when I did the sorting by start time by decreasing, I was like, okay, we could sort by start time and decreasing. So it looks something like this. but it wouldn't work in the case where the end time, we're sorting by its start time and we're going decreasing. But what if the start time had like a really long time frame? Then we would roll out like all the ones after it, right? So I was like, okay, this doesn't work. So I was like, okay, what if we sorted by start time but increasing order? So this also doesn't work, because if we have an activity that starts really early but goes for really long, then we forget about all the activities after it. So that doesn't work as well. So then I was like, okay, what if we sort by end time but we go decreasing? So that kind of made sense to me in the beginning, but at the same time, that doesn't work in the case where, again, you have like a really long running activity, right? Basically, the really long running activity ruins it for the rest of the activities if we're sorting by decreasing order. So I finally ended up with, okay, I think it would work if we sorted by end time increasing. So if we had 4 different activities that look like this, it would look something like this. I'm literally sorting by each activity. I'm just looking at the end time and sorting it in an increasing order. And then I kind of got into the idea of, okay, then how do we break the tie if like there's the same end time for multiple activities? For example, what if there was like an activity that both ended at 5 o'clock but started at different time? Should we sort it then we have to sort it by the start time, right? But then we have to figure out, do we sort it by the start times? Do we sort it increasingly or decreasingly? So what do you guys think about this? So how do we break ties? Yeah, so in my mind, it also makes more sense if we sort it by having the shorter amount of time, right? So we're just trying to be greedy, and we're just trying to select as many activities as we want. So it makes sense to break ties by taking the activity that has the bigger start time, because then we know that the activity takes the less amount of time. So we should do it because we just want to do as many activities as we want, right? Cool. So I think everybody's on the same page now. So now this is the final approach I have. You sort the activities by increasing in time. And this makes sense because you're basically trying to be greedy. So you're just like, okay, out of all the options I have now, what is the most activities I can do? And if you're thinking about the most activities you can do, you're basically thinking, what can I finish first, right? So if you're just like doing all these activities and you're trying to go through them, you're just trying to grab the activities that you can finish first. Then you could do as many activities as you want. So that makes intuitive sense to me. Then once we have the sorted by increasing end time, we pick the first activity after we sort it. And then after we pick the first activity, we remove all the activities that coincide with whatever activity we just did. And then we continuously run this on the remaining activities. But then I was like, so once I come up with a solution, one good thing to do is to figure out each step and figure out if you could optimize each step even more. So this is kind of like the whole process of trying to come up with a plan and then iteratively building on it to make it more and more efficient. But do we even have to remove all the activities that already coincides with the time frame we've already spent? Like, we don't really need to do this at all, right? We could actually just iterate through this array and kind of skip over activities that we can't do anymore. So this is a little bit more efficient because then we don't have to like continuously process our input multiple times. And instead we could just kind of skip over it and move our pointer forward in our array. So what this kind of looks like is if we had a set of activities like this, so we have like 6 different activities here and each has different starts and end times. The first thing we want to do is sort it, right? So we sort it by end time in increasing order. So it'll end up looking something like this. And the first thing we do is we just go through this array, iterating through it one by one. The first thing we look at, okay, we take it. Then we look at 2 and 5, right? That's the next activity that comes after we sorted it by increasing end time. So we're like, okay, can we do this activity? So we can't do this activity anymore because we're already 3 to 4 coincides with 2 to 5, right? So basically what I'm looking at is 2 and 4. So since 2 is less than 4, I can't do that anymore. So I'm like, okay, I can do that. So now we just move over to the next one. So we're basically just iterating through this array of sorted timeframes already and trying to figure out which ones we can take and which ones we can't take. So we can take 12 to 14 because it doesn't coincide with 3 to 4 at all. So I'm like, okay, we could take that one. And then move on to 13 and 14. So 13 and 14, we can't take it, right? Because 13 is less than 14. So that means these two intervals intersect. So we can't take this activity anymore. So we don't take it and we move on to the next one. And eventually we realize we can't take anything at all. And we're just ended up with 2 activity. That kind of makes sense for everybody? Does anybody have questions about this? Let's see. Oh, yes. So that was the other point I wanted to make. So if we're sorting it, would we want to take 13, 14 before 12, 14? So that was the point we're trying to make, right? We're trying to take as the little ones first before we take the big ones. So yes, 13 should come before 14. I'm glad you guys caught that. This other question is really interesting. So for greedy algorithms, do you have to prove why it works? So I don't think you would have to prove in the sense that, write out an actual proof all formally, but you probably do have to prove it at least by convincing the interviewer that your solution works, in the sense that you say, okay, this works because if I give it this kind of input, my solution works because, I'm sorting it this way. Or you could be like, hey, this input works because given my solution, this is how the output would become. Yeah, so this problem is very similar. Yeah, I think this problem is very similar to the merge intervals problem at all. Or remove, yeah, so those two problems are also very similar. Interval problems are also very common as well. Any other questions? All right, so if there's no more questions, that was the end of our greedy section. And starting next week, we're going to go into, or Tony's going to go into dynamic programming. So dynamic programming is like, I feel like greedy algorithms, but way harder. So greedy algorithms are easy in the sense that there's a very straightforward approach once you figure out how to make the problem greedy. But dynamic problems is a lot harder because I feel like you have to figure out one, that you can solve it dynamically. And then two, you have to figure out how to approach it, right? So we're going to spend 2 weeks on dynamic programming after this. But yeah, so other than that, that was the end of our greedy section. And so the one thing I wanted to remind everyone is the hacker rank that's due. So that's the main thing that you want to worry about. And if you're still feeling like uncomfortable about greedy problems, definitely try to work on the extra exercises we provide for you in the course portal. Otherwise, I'll stick around for a bit, but otherwise, yeah, I'll see you all next Tuesday. How often do DP programs come up in interviews? So I think dynamic programming questions, it depends on like which company you interview for, but a lot of times what I've seen is that the interviewer will give you a problem and you can solve it brute force pretty easily, right? But the hard part is trying to solve it more optimally. So that's when the DP part comes in. And a lot of times what I've seen at companies is they have like endless follow-up questions for every question they give you. So the interviewer might give you a problem and be like, it might seem like that problem is really easy, but what the interviewer hasn't told you is that he has a bunch of follow-up questions to actually make this problem a lot more complex. And that's where the DP part comes in. So you may or may not like eventually get to the DP part, but I feel like a lot of times when you're trying to optimize for something, DP does come up a lot. And I also think dynamic programming is just a fancy way of like saying that you should cache what you already know. Basically save what you already know to kind of help you on the next steps. So it might just be like a fancy way of saying, hey, this is one way to optimize your solution by caching already known values, if that makes sense. Yeah, I think Google does like dynamic programming a lot. Google also seems to like graph and trees a lot. Any other questions? Feel free to ask about anything. It doesn't have to be about greedy or dynamic programming. Yeah, I don't know. I guess dynamic programming has like different meaning for everybody. But in my mind, it's basically just saving a value so that you can reuse it later. I think Tony will talk a lot more about this next week, in the next 2 weeks. So Don't worry too much if you don't feel comfortable about it right now. What kind of general questions did you be prepared for? Yeah, so I think it's like this is probably more dependent on like what kind of programming languages you put on your resume. So for example, if you put that if your first programming language that you list on your resume is Java, then you should probably know all the nitty gritty details about Java, right? Like some trivial questions that I've gotten about Java is like, what does the final keyword mean, or stuff like that. But generally, I think you should probably be familiar with object-oriented programming. People seem to really like asking questions about like inheritance or how object programming works in general. So those are good things to brush up on. It might be less applicable if you just put Python. And I feel like these questions, these type of general questions, are also less common if you're interviewing for big companies. At least that's in my experience. What are the four? I don't know the four principles of object-oriented programming. Yeah, that's a good question. Like, what is my experience at Google versus a startup? I think it's definitely a bit of a change where, at a startup, there's only like 30 whole people in the whole engineering team versus Google, there's like 30 people on like one specific team, like Gmail or Google Photos. I think it's a different pace, but I think being at a startup is easy because you know exactly what everybody is working on and you know exactly who's responsible for something. It's a lot easier to coordinate when teams are smaller and more central versus a big company. It might be harder to figure out like how the different pieces work together. So it feels slower because you might have to spend more time figuring out different stuff and figuring out who's responsible for what and figuring out like what each piece of the puzzle comes in. So it is a different pace, but I think it's cool in the sense that everything you work on has a bigger scope. So, for example, at a startup, something you launch doesn't necessarily go out to like a million users or a billion users, versus at Google or any other big company, a feature you launch might go to like a billion users or a million users at once. So it's different paced. The scope of responsibility is definitely different, but I feel like at a startup, you're mostly working on problems that you have worked on before at other startups versus at big companies. I feel like the problems are different than startups just because they're operating at a different scale. Oh, okay. Interesting. I didn't know. Okay, I guess I just don't know a lot of these like keywords that people are looking for when they ask these very specific questions. That also seems like a trivia question to me. I mean, I feel like there's definitely like good interviewers and bad interviewers. Like good interviewers will try to ask about what you know versus bad interviewers will just they know bad interviewers know what they know and they just want to see if you know the exact same thing that they know versus good interviewers try to figure out what you know and try to formulate your interview around that. So and asking these like weird trivia questions sometimes I feel like it's not the best way to see if someone knows something well. Yeah, I feel like interview is definitely a lot of luck of the draw. You could get a really good interviewer who tries to play to your strengths, or you get a bad interviewer who's just like not into interviewing people and hasn't really prepared for your interview. So it's definitely a lot of luck. How did I know what team I wanted to be on? Yeah, that's a good question. I think a general approach that I do is try to find the manager that I trust the most because I feel like your manager is probably the most important part. It's hard to, yeah, you do get it. So I think the general way it works is that once you get through the interview process, you will talk to different teams and different hiring managers, and they'll give you like some options. You could be like, hey, I'm interested in working on like, I don't know, like front end or back end, or I'm interested in working on like a specific product like Google Maps versus I'm interested in working on like a framework, like the framework that powers the Google Maps app or something like that. But I think the main thing I like to look for in teams is the team itself, like some like people I would want to work with and be around like 8 hours a day. But the biggest thing I think is the manager good? Because if you have a bad manager, it's really hard to progress in your career at all, right? If you hate your manager and you don't think like you're gonna work well with him, it's gonna be really hard for you to go into work every day, and it's gonna be really hard for you to get good reviews. So I like to look for managers that I think actually believe in me. I feel like it's really important to have a manager who, one, is good at managing, but also two, really you feel like they trust your skills and they're going to give you more responsibility. Because even a manager who doesn't think you're going to be able to do well, then it's going to be really hard to do any interesting work. But if you have a manager that you feel like you have the support of, it's a lot easier to get more impactful work, and it's a lot easier to go to them with problems, and it's a lot easier to just resolve conflicts. So I try to look for people who I think will be good managers, I think is the main thing. At big companies, I don't, it's like not encouraged to change a few months in. I mean, obviously, if you're like having a really terrible time, then it's probably a better idea to switch teams. But I don't think it's generally encouraged to switch teams until 1 year, at least until you've been with the team for 1 year, so that you aren't just like jumping around all the time trying to figure out what to do. um, oh yeah, this is a really interesting. So how do I decide like what specific type of thing I wanted to do in computer science? Because there's all these other things, right? Like there's mobile development, and within mobile development, there's Android and iOS, and then there's like web development, front end, back end, or you could do full stack, and then there's game development, and then you could do like data science stuff, or you could be a product manager, or you could be like a data scientist, or you could be like machine learning. There's just a bunch of stuff, right? So at least for me, I basically just got a job in the first job I got was back in Java, and that's only just because I knew Java really well. But then I realized backend wasn't really interesting for me because I like seeing people. I like it when I can see people use something I actually built. Backend is kind of like abstract because you can't be like, hey, look, this is like your app is calling the API that I made or something like that. It's just like not exciting as, hey, I actually built the screen for this app you're using, right? So I just wanted to do something more UI. And because I knew Java really well, that's how I got into Android. And I thought Android was really cool because I could actually build apps that would run on my own phone. So I thought that was really cool. And so that's how I stuck around with Android. Yeah, so I'm one of those type of people who need like instant gratification, which I think is why mobile was fun for me because it's something that I could build. And if I have an idea for something, I could immediately build it. And I think that's why I was really drawn to Android versus like backend. I could build all the like backend stuff, but then if I wanted to do the UI, I was like, I don't know how to do that. So that's why I think Android was really interesting. And also like everybody has an Android phone or everybody has some kind of phone. So it's really cool to be able to be like, hey, I could actually build an app for something I have an idea of. Like what are the most common questions I get? I feel like is friends and family being like, hey, I have this great idea for an app. Do you think you can build it? So it's cool to be the person who's like, hey, I have this great idea for an app. I could build it myself. So I do use an iPhone. I feel like iPhones just work better in general. But overall, globally, I think Android is more common than iPhone just because at least people in different countries have less of a budget. So it's cool. I do use an iPhone though. um, yeah, so for people who want to like kind of move around, because a lot web development is a lot easier to start off with. I don't know how it was kind of hard for me at least to switch from backend to mobile, just because then you're kind of starting from ground zero. So doing side projects really helped show that, hey, I have some experience in development, but these are some side projects that I did by myself to show that I could actually do something else other than what I have experience in. So I think building side projects is a good way to show that you want to do something different than what you've been doing. Because one, you already have experience building and shipping products, so that's good. Now you just need to show them that you could do something else outside of what you've already been doing. Is it okay to tell companies you're interviewing with that you're not sure what kind of track you want to be hired into? Yeah, I think that's totally, I think, well, okay, so I think that's fine for big companies where there's a lot more flexibility. I think for startups, that'll be more, less okay just because startups need someone to get in there and start doing things fast, right? They don't have resources for people to get ramped up on a new type of field. So I think for startups, they're looking for people who know exactly what kind of product they want to be working on, what kind of like stack they want to be working on. Big companies are totally open to generalists who are just good coders and who are good problem solvers. And then, because I think the hard part is finding someone who's curious and good at coding, right? It's not as hard to pick up a new language because you can just, most of, like, I feel like 90% of any job is learning on the actual job. So at big companies, they have more resources for you to get ramped up. But at startups, they really need someone to be able to start contributing like right away. Yeah. So I think in week 12, we have another panel, and that might be a good time to ask other questions if you have any that comes up to mind. JavaScript is quite hard. I think JavaScript is hard because of its unpredictability, at least in my experience. I don't know. I'm actually more just a Java person. I haven't done much JavaScript. Cool. So if there are no other questions, I think I'm going to go ahead and end the session, and I'll see you all on Tuesday.